Hi, I'm Lily and I'm 16 years old. Behind the camera is Connor and he's 15 years old. This year we've been investigating the falling slinky. When a slinky falls, each coil appears to remain stationary until it's hit by the one above. This creates a domino effect until the last coil is hit and the slinky falls. We find this interesting because during the first phase of the slinky's descent, the bottom remains stationary as if unaffected by gravity. For our space-safe experiment, we want to find out what would happen if the bottom of the slinky really was unaffected by gravity. This is how we can explain the phenomenon. Before release, the forces are balanced at each point in the slinky. The weight of the slinky pulling down is balanced by the tension pulling up. The higher up the spring, the more mass that's being supported and the more tension there is. This is shown by the spacing between adjacent coils, which increases as you move up the spring. On release, most of the spring remains in equilibrium, as all coils aside from the top one are still being acted on by the tension force. Only when the spacing between the coils decreases does that point in the spring start to move, therefore the domino effect occurs. Our hypothesis is that if the phenomenon were recreated in space, the slinky would collapse towards the centre of mass, rather than towards the centre of the Earth. This is because the tension force on the slinky would be unopposed, therefore the coils would be evenly spaced. With the elimination of gravity, this would be the only acting force, so the tension on both sides of the slinky would pull it into equilibrium. Obviously, in space, the slinky would not pull itself down as it does here on Earth. So on the space station, we would need an astronaut to pull it apart manually. Our proposed method of testing would be for the astronaut to pull the slinky apart and then let go and observe the phenomenon. The astronaut would then repeat the test with the mass attached to one end. This would change the centre of mass. Therefore, if our hypothesis is correct, the slinky would move to a new place, exactly where the new centre of mass is. Thank you for your time and I hope you enjoyed our experiment.